point of division that you guys see, and you can respectfully address it and let us know, or let someone know, or I don't know. That could be helpful. All right, we're on number 4 and number 5. You guys have had a little bit of time. Shoop, shoop, shoop. Does anybody see the matryoshka in number 4? Yeah, this is the problem. But did you know how to rewrite it? If I were you, I wouldn't have taken it there. I think you would get tricked by the trig notation. You're not supposed to get tricked by the trig notation, which is why I say don't get tricked by the trig. Did you remember from last year that sine to the 4th of x is the same thing as sine of x to the 4th? Oh, it's so easy, and yet you forgot. So it's a u to the 4th, right? It's a 5u to the 4th. Now, some of you might want to use that chain rule trick and be like, oh, hey, chain rule trick for power rule, remember? If you have u to the n, you can go ahead and just say n times u to the n minus 1 times u prime. But if you are using your notation and trying to make sure that you have it down really, 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 really well, I'm going to go ahead and take this guy off to the side just for a second. I'm going to say that f is equal to 5u to the 4th. I'm going to say that u is equal to sine of x. I'm going to go ahead and take the derivative of, which is 20u cubed, times the derivative of sine, which is cosine, which translates to f prime of x is equal to 4 plus derivative of 4x plus 20 cubed sine cubed times cosine. Or derivative of the outer, 5 blop to the 4th is 20 blop cubed. Keep the inner unchanged times the derivative of the inside. We can think 5u to the 4th is 20u cubed times u prime. But we wouldn't leave it quite like that. I suppose you could pull out a 4 if you really, really want to. It's just not going to really help much. That cubed comes inside the sine. That cubed comes inside the sine. How are we doing? What made the difference for some of you? Yeah. Don't get tricked by the trig notation. Some of you might want to make a quick little star on this one because this notation, this guy, is something that can definitely confuse you. Number 5. Who got there? Who got there? I'm going to go a different way this way, or this time. I'm going to go ahead and say, hey, isn't this just a tangent of u? And, ooh, sorry, you're not ready for that. Let's here we go. That's for integrals, and I was tutoring a kid in integrals yesterday. U prime. Are we okay with that u, tangent of u? And that u prime, bring down the 1/2, subtract 1, negative 1/2 times, well, u prime, x prime is just 1. So I'm going to use the rule, f prime of tangent of u is secant squared of u times u prime. I'm just going to plug in. Secant squared of who? Square root of x times who? 1 over 2 square root of x. And so my final answer is secant squared square root of x, which could have a parenthesis and could not have a parenthesis, over 2 root x. Dun, 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 dun. Left me hanging. Thank you. Yeah. Mm-hmm. It didn't work out? Were you doing like the F and the U? Yeah. Hold on. No, that's good. Let me just take it off to the side then. So your F of U, or you could just say, right? Your F would be tan of U. Your U would be square root of x, which I still would have rewritten to be x to the 1/2. So then when you take your derivative f prime of U times U prime, then plug back in your U. I think it works. Where'd you get stuck?
Oh, because I wrote down the 1/2
Yeah.
in front of the tangent, and then I put
Oh. Got it. That's illegal. Okay, so what you did is you wrote this, first of all, which isn't a bad idea, but when you rewrote it, what you thought was that this was for the whole tangent, instead of realizing it's x to the 1/2. Remember, there's if a trig ever has a power, it's always going to be on the inside so that you can never confuse it with one on the outside. Sorry. It's going to be on the inside so that you never confuse it with a power of an argument on the outside. Does that make sense? Good question, though, because if it was like a big old square root of tangent x, then yours would have been right. You just saw it a little bit wrong. Okay. I want you guys, as a group, I'm going to give you guys some individual time. Not tons, but some individual time. Rewrite first. And then as a group, solve it step by step. Choose a way. You're going to do F and U, or are you going to choose F and G? Are you going to try to do a shortcut of the chain rule, like U to the N, or tangent of U? If you want my advice, I think you're going to have to use either F, G, and H, or F and U and V. Take a second. Let's see how far you can get. Rewrite, decompose. No, start talking. No, right away. Collaborate. Well, you're going to have to choose a way. Like your group is going to have to go the same way. So right now, start talking. Which way are you going to do? F, G, H? Or are you going to do F and the U stuff? So I want you guys to go the same direction. So you choose. Whoever has a strong opinion, make it known. Decompose that function. Decompose that function. Aww. Look at that encouragement. Real quick, vote. Who did FGH? Who's trying FGH? Who's trying F and U stuff? Okay. Keep going. I'm just going to rewrite. I'm just going to decompose. Do you know who the outer matryoshka is? Who the middle matryoshka is? Who the innermost matryoshka is? Who's the outer? Fourth power. Look at it. Don't look there. You gotta think there. Tricked by the trig notation. Okay. Reevaluate. The outer is the fourth power. What's going to be the middle guy? Tangent. Does that make sense, though? And then who's the inner guy? X cubed. So reevaluate. I'm going to show it too. Reevaluate. The outer is x to the fourth. The middle is tangent. And the inner is x cubed. See if that makes sense if you're trying to do the U notation. You haven't actually seen this yet this year. F has a blop to the fourth. We call that blop U. U is tangent of new blop. We call new blop V. And new blop is x cubed. And x cubed x. It's okay. Think every guy needs a derivative. Every guy needs a derivative.
Yeah, I know, but whenever you're dealing with this,
I'll write that one. Well, it's all about how many shells you can peel off. I can peel off a fourth, then I can peel off a tangent, and then I have my x cubed. So I know that there are 3. You could peel off the cubed, but then there's an x, and I don't mind him. So it's kind of like the last peeling off will reveal the x. So there's 2, there's 3, I'm done. Onions have layers. And if you guys want to think of the other notation that we don't use very often, this one would be dy du times du dv times dv dx. And this, Michael, is why we get to stop, because we finally get to the x's. We finally get to the x's. And then we're like, oh. Hey, guys. Whatever you're looking at, what's the derivative of the outer? 4u cubed. If you're using U notation, 4u cubed. Times, what's the derivative of? Secant squared of v. And what's the derivative of v? 3x. And finally, I've gotten to x's if you're doing the U notation. Now all we have to do is go back and plug in. So f prime of x is equal to 4 who cubed? Derivative of the outer, keeping the inner the same. It's u. And who's u? Tangent of x cubed. Tangent of v, who is x cubed. Or you can think, derivative of the outer, keeping the inner unchanged. Oh, times, then we had to peel off the 4th degree. We got to this guy. His derivative was secant squared of who? Of x cubed. Times, then we peel off the tangent, and finally we've gotten to the x cubed, and we have, so our final answer would be 12x squared tangent cubed of x cubed secant squared of x cubed. Like, it works, right? Like, I could give you a crazy f of g of h of j of k, and you could just work through the process, and as long as you could decompose it correctly, just take the derivative piece by piece. Bunnies multiply, it's always multiplication. And you peel off one by one by one. And some of you are seeing, wait a minute, okay, I'm following the steps, but I think soon I'll be able to mental math something like this. And I think so too. I have another one. But any questions on this one first? Well, I gave you like a really hard one so you saw it like in its full application. Because could you do this again? Yeah. Just what if this was something like square root of w? No, it's okay though. If it was square root of w, what does that mean? Then there would be a w that was like x cubed or 3x squared or x plus 1, right? And you would just do the same process. You would just have an extra piece to keep going. So we could technically do this all day. We just have to be able to look at an original function and break it down first, whether literally writing it out or in our heads to see the outer, the middle, the inner, and sadly my Matryoshka doesn't, well, if we did have 4, don't worry, I got you. If we had 4, I would go to the old school one I was using. And we could have an F, of a G, of an H, of a J, of a... Except he's not colored. I know what he's saying. Andrew Aganagwa a few years ago graduated and didn't end up finishing the coloring. It was so sad. Michael, what's your question, bud?
Can we just use any letter?
Technically. Just, I want your brain to be able to jump to the rule in a way that's consistent. Does that make sense? And if, remember, well, let me show you guys something. We might not do this one right this second, but pause. This is a very, 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 very good AP type problem where you have no clue what the function is on either one. You don't know the actual who is F and who is G, but you don't need to because you have a rule. Now here's the struggle. If you didn't ever memorize the chain rule with F and G's, you'd kind of be lost right now. So in that way, it's really nice that we're studying F's and G's because then we'll be ready for AP problems where they're like, you better know the FG notation. But then I really like the U's and the V's because it simplifies things a little bit. Because for some of you, this whole like, hey, all these guys having X's when they're not really X's, when they're really U's, it gets really confusing. Even though technically it does work, you plug in, you plug in. For most brains, it's a bit easier to process this one. Okay, we're going to come back to this one in just a second, but Nick did ask for another one. So, ready, set, go. You guys got it. Yeah, you can work in your groups. Yeah, but think of the outer, what's the big picture going on? But wait, make sure you're labeling what you're doing. Why are you doing the quotient rule first?
Because I want to be able to break down the power after.
She's thinking u to the 17th. And what's the derivative of u to the 17th? Shh, go. Times u prime. So, Janelle, you could label it u prime equals, right? This one doesn't even have an h. Yeah, if that makes it easier. If anyone's stuck and you didn't hear the hint was Janelle's looking at this like you. You have a team. Reach out. You're not on your own.
Guys, when you guys are doing it together, You have to make that negative. So the 2x negative x squared. If you bring it up. So I
Make what negative?
distribute. You want to bring that left as a negative x squared. If you have to change it to, or you just go x squared.
Oh yeah, I see. Yeah.
For the bottom one.
Oh, I would just stop here and do u prime with quotient rule. Are you trying to do a v? Oh, so bottom just stays the same. D top is a positive 2x. Top D bottom is a negative 2x.
Then you still have just cancel out.
That's what I got so far.
Because then it would cancel out.
Did you do the green trick?
Yeah, I don't distribute the negative.
Yeah. I mean, yeah, or just do a negative times a negative as a positive. I think that might be easier.
Because then when you distribute the negative,
And then distribute the other negative.
how are we gonna get there?
Because if you bring the negative in, you have to bring that negative in. So it'll be positive either way.
So it does cancel out.
Yeah.
Did you pull out?
Okay.
Yeah.
And then the negative negative will just be 1 plus x squared, right?
Wait, Misty, don't do anything else.
Okay.
You just like literally skipped like.
Sorry. Because of my green trick, I saw there was a 2x in common. Okay, I'll pause. Me too. You guys got it. You got it.
Yeah, it does. It's all it just all cancels because it'd be 1 minus. Or.
Great. Okay, can't say I'll try. Okay, thank you.
So then you bring down.
I love how x first letter. That's so definitely is not one. Guys, we actually did it.
Okay, and then that's 17 times 2.
34.
Misty, I did it. Watch it be wrong.
I don't know. I think you might have it right. It's sounding good. Michael, where's the encouragement?
When there's like a power, because then it just breaks down. I don't know why.
What? What?
Wait.
Oh, wait. Okay,
Do you guys lose too?
I think they can't out things.
1 plus 1 is 2, and 2 times 2x is 4. You were almost there.
Oh, dang it.
And 4 times 17.
It doesn't cancel out with the bottom.
Well,
Oh.
The bottom top with the bottom because we thought it was 1 minus x squared times 1 plus x. So I was like, oh.
Good job. Yeah.
when you pull out, it's just going to be, there's an addition in between. You were thinking multiplication, but there is an addition in between.
There's no way this thing was 2x. But I'm like, hey, they
So
know
we
what
end
they're
up
doing.
with 68x 1 plus, because 4 times 17. So the 16.
All over. Dude, you guys it. Whoa.
You could have stuck it to the man. But do you see how they're like?
Did that say over 18?
Because it's to the 16th, to the 16th, and then there was 2 more. So then to the 18th.
Where did you get the 18 from?
Because when you raise this guy to the 16th, he's repeated 16 times. So the numerator is to the 16th and the denominator is to the 16th. And then there's 2 more. 16 plus 2 is 18. It's this like bases, yeah. Like bases. Yeah. Yeah. This guy could be rewritten as 68x 1 plus x squared to the 16 over 1 minus x squared to the 16. Like they're both to the 16th because it's rewritten 16 times. And then this guy, look, it's like bases, is also squared. So 16 plus 2 is 18. When you multiply like bases, you add their exponents. Pause. Pause. It's not whether you did it perfectly, it's whether you did it perfectly. I think so. I think so. I don't think it's impossible. That's the main point. Does it look impossible to you? But you understand where the answer came from. So is it impossible? Okay. Any questions? I think, long story short, we need practice, right? Huh. Go ahead.
Wait, how come the 1 plus x squared over 1 minus x squared is on the inside? Like, how do you know that's G?
I followed her work and I was just
Oh.
I know it's U.
Because if I was to break it down, you see the 17th power, right?
Oh, you went to the original problem. That's why we did it wrong.
Oh, what'd you guys do?
We just brought down the 2x.
Well, you brought down the 17 and made it 16, right?
Yeah,
And then you thought quotient rule. Like you thought of this, right?
Yeah, we just didn't plug in 1 plus x squared over 1 minus x squared. That's where it
Oh, okay. Oh, okay. But see, it's
plugged
I.
in 2x.
Oh, as the inner.
Yeah, that's what we did.
You did what I would call a mathematical abortion. Because what'd you do? You took the derivative of, where's my matryoshka? You were like, I can derive him and him at the same time. But it's inside. You're not supposed to, right? You have to deal with the outer. Take his derivative, keeping the g and the h and all that stuff inside. This one only had g. No. That's the most common mistake, is you try to take derivatives of everything all at once. But you can't. You have to take the derivative of the outer, peel it off, times. Now, when you times, you're peeling it off. So derivative of the outer, times. Okay. Oh, now it's okay. Does that make sense? Okay. And that's why I have in the words derivative of the outer, keeping the inner unchanged, keeping the inner the same. Time. Bunnies multiply. You have to have that guy come out, and then you can go to him. And then et cetera, et cetera, et cetera, et cetera. Or the other way of looking at it is with the u notation. Take this derivative first, 17u to the 16th. U to the 16th times u prime. Had to be separate. Had to be separate. Okay, any other clarifications? These are really important ones, guys. Oh, because this ended up being 2x times 2, because the x squareds cancel and 1 plus 1. Yeah. Anything else? Did I lose anybody else? Okay. Yeah.
Can you go back to the first one that we did? Or like the one that was just before this?
This one? No, this one?
Yes, that
Yeah.
one. It's like four. So, I have a question.
Yeah.
On the 10x cube, did you distribute the 3 to the 10? Not
I rewrote the trig notation. Because proper trig notation doesn't list trig, whole trig functions raised to powers, doesn't list it like this. Trig notation says we'll call that tangent to the 4th of every time x cubed. So how we had to start the problem is where we had to finish with simplifying the answer. Because the answer says tangent x cubed, tangent x cubed, tangent x cubed, but the notation for that is tangent cubed of x cubed every time. Does that kind of make sense? So there's no deriving going on. There's no technical distribution. It's just this is the notation for what this means. And so then I go back to the proper notation at the end. Is that cool? Yeah. So what do we do when they give us something like this? We'll see tomorrow. It'll be an AP practice. We'll do back of the homework spiral. I want you guys to get this because a couple of you guys asked for derivatives of ln. And we're not going to get all the way there. See why I'm apologizing that you saw some ln's in homework. Sometimes I forget what basic rules you've covered. And I split section 2.4 in half. we're going to focus on logarithms tomorrow. And if you guys notice this page, we're going to start with pre-cal. We're going to start with pre-cal review of logs for a few different reasons. You do? There's usually very many opinions. Some people are like, nah, calc's way better. And some people are like, no, I actually miss pre-cal sometimes.
I miss first semester pre-cal. Let me clarify that.
Trig. Interesting.
First semester pre-cal was like, let's go.
Yeah, exactly. Second semester vectors, I was like, I give up on taking this class.
We're technically supposed to do vectors before the semester break. It's kind of funny, but oh well.
Semester, I got like
hated
A's just
vectors.
from guessing. It's so weird.
Second semester, like,
Yeah, you know what I got for guessing?
It happened like
Far from me.
yeah, I got like a 92.9.
Okay, we're going to have time tomorrow. What I want to show you before you get out today, the derivative of ln of x is 1 over x. So, question, what would be the derivative of ln of u?
1 over u.
Ah? No, keep going.
Prime.
U prime.
Good job.
Yeah, see that?
So if you see an ln in homework, you know what to do. 1 over u times u prime, or just 1 over x if it's just an x, because times x prime would just be 1. All right, finish up section 2.4, technically A, homework for tomorrow, homework number 11. And then we're going to bust out, after some AP practice with those funny ones where they don't actually give you function, and grading our homework, we're going to bust out logarithmic derivatives. Bye, cool kids. I'll see you later. We're going to see a phoenix rising again from its own ashes tomorrow. It'll be fun. Happy Thursday. In period 2, yeah.
like, basically, it's our whole class.